Alright guys, so check it out. Yesterday, because we had some issues, I didn't get a recording, so I'm just going to double this up for 5 and 6, which means I'm going to review yesterday really quick. So what I'm going to do is have you guys flip your periodic tables over to the back side. Okay. When you guys are flipping to the back side, you guys should be able to see where we have our equations we balanced from yesterday. So I'm going to zoom in on those guys. Alright, cool. Alright, you guys, so a couple of things. We had Na and we had Na and we had Cl, and then they combined together to make NaCl. Okay? These guys together collectively are known as reactants, and then when they end up, they are products. Okay, so if we were trying to make this and there was something extra, could we refer to that as a byproduct? But would it still be a product? Okay, cool. Alright. Then you guys, this says gives or yields, okay, it's creates. We had one Na, one Cl, so we wrote 1 and 1, and then we came up with one NaCl, okay? When we circle this, because it is a, and then this little guy right here that's understood, it's a 1, is a subscript, okay? We guys got those taken care of. Okay, we have this little dotted line because that represents kind of like the equal sign, so we have to have them equal on both sides. You guys did a good job with this. Now, you guys didn't know this, but you were doing a specific reaction, okay? We had two things, and they became one thing, and so for that reaction, we call that a synthesis reaction. So if you guys want to write down synthesis, okay? Synthesis reaction. Okay, and then we had one just below it. Recap on that. Cool. All right, you guys. So this time we started out with water. Okay, we had to balance the water equation. All right, and on this one we had H2O. Okay, and then we separated into what two things? Hydrogens and oxygens. Okay, so check it out real quick. On here, you guys. These little subscripts. Do we create the subscripts? Who creates subscripts? Nature creates subscripts, right? Okay, and so we can mess around with the coefficients, but we don't mess with the subscripts. So when we look at this, we know that we're going to end up with H2s and we're going to end up with O2s. All right, so looking at this, we have 2 H's on this side, 2 H's on this side, so 4 H's on this side, and then we have 2 and 2, which is 4 H's on this side. We have 2 O's on this side, and then we have 2 O's on this side, so this is balanced. Okay, so this time we took something apart. Okay, does anybody know what kind those guys are known as? Decomposition reactions. Okay, so you guys should write decomposition on this one. Just kidding. There we go. Decomposition. Okay. Alright, you guys, so we got decomposition. Okay. And so now we're going to introduce some new reactions today. Some new reactions. So we're going to do 2 more. Okay, so out of the space you guys have left, you guys have to. Some of you guys, these are a little bit longer equations. So you guys might have to write them a little bit slanted to make them fit. I'm going to try and not make them slanted, but once again, you might have to. So I'm going to recommend that you don't write this down until I have the equation completely written out. Okay, make sense to you guys? All right, so like I said, you guys have the rest of this whole column to write the next 2. So I'm going to skip just a little bit of space and start on this one. Okay, so we're going to start out with, let's see here, a dash or a space. Okay, and this is a Z, not a 2. Zn, what's that? Z. Okay, plus then we have HCl. Okay, so HCl is hydrochloric acid for sure. Okay, and then it's going to give, and then we're going to have, oh, I gotta leave a space for that. Let me erase that real quick. Oh, that was a lot easier than I thought it would be. Okay, it's gonna give space. Let's see. ZnCl plus, and the last part is gonna be H2. Okay, cool. All right, can you guys see that? I'm gonna read it for you guys. I want you guys just to have a space for that, okay? So you guys see where I got this? So I have a space right in front of this, and I have Zn plus a certain amount of HCl gives an unknown amount of ZnCl, okay, and H2. You know, it's funny, I just noticed a mistake right here. The Zn L or Cl has to be 2. It has a subscript down there. It's got a 2 for a subscript. Okay, so I'll read it off again. Space Zn plus space HCl gives space ZnCl2 plus space H2. Okay? Now let's talk about how we balance this. Now before I just told you guys just balance them. And yesterday you guys did a really good job on practice. But I want to talk to you real quick. In nature, we have these little subscripts. We can't change the subscripts, but we can change the coefficients. So before I even start balancing, now I look at it mathematically and I just start to balance it before. I'll explain. Okay? See how there's a Cl2 over here? How many Cl's am I going to need on this side? 2. So I just start by putting a 2 in here. Now I might have to change it later, but it's a good start. Okay? So I got my 2 in there. And then how many H's do I have on this side? 2, because nature says so. So how many do I need on this side? 2. So look at that, that's pretty convenient, right? So now when I draw it out, I think we're actually going to be okay. I have a Zn. All right, I have HCl, HCl. And then down here, I'm going to have Zn. Oh, I'm going to have Cl, ZnCl. Okay. And then I'm going to have HH. So let's look and check now. So I have 1 Zn, I have 1 Zn. I have 2 H's, I have 2 H's. I have 2 Cl's, and I have 2 Cl's. How many of you guys have to put 1s in those blanks? I know how it is. I'll put the 1s in there too. But when there's not a 1 in here, it's understood, right? But does that make you feel better as far as what it is? Okay. Does that make sense? You guys are doing a good job on this. I know it hurts your brains.
Wait, what is that? The product side, what does it say?
So on the product side, we have Cl, Zn, Cl. Is that Cl2? That's just kind of how it sets up. Okay. Now what's funny, you guys, is this is a particular kind of one, kind of reaction. And sometimes the reaction is explained like this. We have A plus, let's see, actually, B, C, and it gives AB plus C. Okay? Now, in chemistry, you're like, okay, that's the thing. But in dating, it totally makes sense. There's somebody that you walk past every day and they're making out next to their locker. And every day you put your little hand up and you're like, awkward, okay? And then one day you walk by and they're still making out, but it's a new girl. That is a single replacement reaction, okay? Oftentimes, it results in salts because somebody's always a little salty. Anyways, we'll move on. Okay. All right, you guys. So do you guys see how this is a generic way to write this out? Okay. This is just a single replacement. Okay, single replacement reaction. Okay. Guess what we're gonna do next? Okay, so that gets even more awkward. You go down the hallway where everyone makes out. Don't tell me where it is, because then I have to go there and bust it up. But every school has one. And you see all the couples making out, and then you come back after January, and you do a double take because you're like, whoa. Because they just traded out. And you guys are like, oh, that's horrible. Welcome to high school, okay? All right, so we're going to talk about double replacement reactions, okay? And so once again, I'm going to write this out, and then I'll let you guys write it out after. That way we don't mess it up too bad. Okay, we're going to have a certain amount of Na2S, okay, plus we have a certain amount of HCl. That's going to give a certain amount of NaCl plus a certain amount of H2S. Okay, so I'll read that off to you guys again so you guys can make sure you can read that guy. Okay. All right, so we have a certain amount of Na2S, Na2S, and a certain amount of HCl gives a certain amount of NaCl and a certain amount of H2S. H2S. Do you guys see how the players just swapped? Okay. So now, once again, using my tricks here, you can't change subscripts. So let's look at the subscripts that are doubled. So I know that I'm going to have 2 NAs on this side. So what do you think I'm going to need on the other side? 2 NAs. So I can put a 2 right here to start. Okay. Then I know I have 2 H's on this side, right? So you know I'm going to need 2 H's on this side. So let's see if that fixed our problem. Cool? All right, so I'm going to draw these out. So I have an N, A, S, N, A. I have 2 HCl's. Okay. I have 2 NaCl's. And then I end up with 1 HSH. Okay, so let's look at that. I have an Na and an Na, right? Na, Na. I have an Na and an Na, so that's good. Okay. I have an S and I have an S. I have HC, or sorry, I have HH. I have HH, and I have Cl, Cl, and Cl, Cl. Balance the equation. Who has to put the ones in? So you guys do, that's fine. Put the ones in there just to make sure we're done. Okay, so generically speaking, all that happened here was we had AB plus CD, and now we have AC plus BD. What's this called? Double replacement. Cool? That was the easy part. Oh, what was that? Oh, huh?
Yeah, I heard that.
I heard that. Alright, you guys, so I'm going to zoom out here. Once you guys get this done so I can show you where we're working on our paper. Alright, you guys, so we're back to our paper again. Is this kind of what you guys' looks like now? Okay, so I want to talk to you guys about the 2 quadrants we're looking at, okay? So everybody has their paper open all the way up on the back, okay? So open it all the way up. I want to tell you guys what this dotted line represents. This dotted line is a fold, but if you guys look up here, there's 2 little folds on each side of this, okay? See where my hands are? And for you guys in video world, there's like a little fold that runs along here, okay? There's a little fold that runs along here, okay? But we're going to be working in these 2 boxes first, and then we're going to work in these 2 boxes below them, okay? And so to clarify that, where these 2 boxes are going to be first, okay? These bigger areas, and like I'm going to put a little dotted, line on this that I don't want you guys to put, okay? So the area we're working first is going to be here. Okay, and then the area we're working second is going to be like here. Okay? Yes. I'm actually going to come around and show you on your paper. Cool, but I want to clarify this first. So you guys might even have like a little dotted line, like you guys have little folds right here we might see. Okay? But what the trick is in a minute, I'm going to have you guys write photosynthesis. And photosynthesis really small is going to go right across here. Okay. Oh, I started writing the wrong one. Okay, it's going to go across this thing, right? So it's going to go right up here. Okay, so I'm going to erase this in just a second, but I'm going to go around now and tell you exactly where we're working. Okay? So first we're going to work in these 2 boxes, and then we're going to work in those 2. So we're going to work, see how there's a fold right here? We're going to work in this area, together, and this area, and this area. Okay? So these 2 boxes, there's the line that splits it. These 2 boxes, there's a line that splits it. These 2 boxes, there's a line that splits it. These 2 boxes, there's a line that splits it. Some of you guys will put a little X right here. Okay, you guys can put a little cross right there to separate them. Okay? And yeah, you can put a little cross right there to separate them. Okay? So you guys are working these 2 boxes, then these 2 boxes, you put a little cross right here to separate them. Okay? Cross right there. Okay? these two boxes. We're going to work in these two boxes.
No, just the 2 boxes.
These two boxes. These two boxes. These two boxes. Got it. So we're going to make it a little bigger. So you're going to put the cross here. You're going to work in these two boxes first. And then these two boxes. Erase that out. Just a little bit. Okay. Two boxes here. Yeah. And then two boxes. Two boxes here. So yeah. So you're working here first. Here first, here second. Yep, got it. All right, you guys. I think we got everybody separated out. So I'm going to undo a little bit. All right. Maybe.
Sure do have a lot of dots to erase.
I do have a lot of dots to erase undoing. But if I erase it, it'll be like too much. It'll be too crazy.
No, your eraser doesn't work.
It does, but I start to erase the other guys and it gets crazy. Actually, I can do it now that I got photosynthesis out of it. Maybe. He doesn't like waiting.
But you treat him as one.
Just gonna wait on that for a sec.
It's still taking dots off.
It still is. Uh-oh, we might be erasing too far. Now it's gonna mess stuff up, watch. It is. It's taking off my double replacement. All right, there we go. Double replay. All right, we're back to double replay. Okay, does everybody know where we're working now? I'm gonna mess your whole world up because I'm gonna zoom in now. All right, so we're gonna go in like.
First left box.
That's crazy close, right?
So you're gonna be working on this one. So these ignore those lines. I can't just ignore them. They're there.
All right, do you guys know where I'm at on my paper?
No.
No. All right, so where I told you guys to put that cross is right here. Okay, so I had you guys put that cross on. It is right here. Okay. Wow, my pencil does not want to go. Okay. All right. So what we're gonna do is we're gonna work in these two boxes first. Okay. And you guys need to understand that this is a very complex chemical reaction. I'm gonna give it to you guys completely balanced, and then we're gonna draw molecular models to represent it. And then we're gonna do the flip side for respiration because they're opposites. Okay. So photosynthesis, I'm gonna write it across the top here. Okay.
Why is your marker so thick?
Because it's so tiny, which is really funny. But you guys will look, it'll look all right in a second, okay? Photosynthesis. All right, who does photosynthesis? Plants do, so I put my little flower guy here. Okay. There's my little plant. Okay, now, what's important about photosynthesis is we need to understand that photosynthesis is a one-directional chemical reaction, okay? And how the chemical reaction starts is with the sun. Okay, so far you guys should have photosynthesis. You guys can see I have my sun right here. Okay, now we need some other players, so it's not just sun. We also need, plants need what?
Water.
Water, okay. They also need what? Oxygen? Do plants need oxygen?
Carbon dioxide.
Carbon dioxide? Okay, so here we go. We're going to give them 6 waters. So we're going to go 6H2O. Okay, plus you said carbon dioxide, right?
Yep.
So we're going to give them 6 CO2s. Okay?
Should this all be in the first box?
like the first box or can it
Yeah, so do you see where the dotted line is?
Yeah.
I wrote photosynthesis on this, and I put my arrow here, which is directional reaction. Okay, and so that means that this is the first stuff. So what is all this stuff?
That's the
It's the reactants, and then what's going to go over in this box? Products. Okay,
So
good to go.
can it go like in the 2 boxes?
Yeah, I can go in the 2 boxes. And now that I unconfused you guys, I'll show you mine. Okay, mine's a little bit squirrely, but you guys are about to do this whole mess.
Well, no one can see it.
I know, that's okay. But that's why I know where you're kind of working. Okay? I just don't want to show you guys my big giant panda. That's for tomorrow. Okay, we'll move on. All right, so now, you guys are like, is this chemistry? Sure. All right, so check it out. Now, this is the most difficult thing to draw, so I'm going to show you guys how to draw it. Ready? It's on my whiteboard, okay? But it's not just enough to know what it looks like. I need you guys to know how to draw it. So do you guys see the part that I circle dotted here in blue? Okay, we're going to draw that first because it's going to give us an idea of where it goes on here. So look, if we draw this straight up and down, we're going to draw HCCHOCH. Those of you guys in video land, you should just like fast forward and then come back and draw it. But you guys will see we're going to draw the center one. And then look, to the left, we're going to need space for like 2 or 3 letters. And then to the right of this, we're going to need space for like 5 or 6. Okay? All right, so in a second, we're going to draw that. But first of all, what are we actually drawing? All right, we're drawing glucose. Does anybody know what the glucose is? It's sugar, but what is it? C6. Okay. What is it? H what? H12. And then O6. All my PBS kids are answering. How do you guys know that? What's the ratio we're looking for?
1:1.
1:1. When we do sugars, we always look for a 1:1 relation. For a ratio? For ratio? I don't even know what word that was. Okay. And then what's the byproduct? What do we like that plants put out? Oxygen. So in this case, it's going to be O6. No, O2. It's going to be 6 O2s. It's going to give us 6 O2s. Okay. All right. So I've given you guys a balanced chemical equation. Now we're going to go into that model that I was just showing you guys, because I'm just trying to give you guys some ideas here so you guys can get your spacing going, okay? So let's draw the easy side first, okay? So we have our carbon dioxide, which we write as OCO, okay? The next one we have is H2O, but we write it as HOH. How many times do we have to write that? 6. Both of those need to be written 6 times, okay? All right, do we have all of our reactants stacked up correctly? So the reactants are sitting there in a plant or around a plant, and then we add sun, and fun things happen, okay? All right, now it's gonna give us sugars. Okay, so plants make sugars, and we like sugars. So we're gonna start out, and I told you I'm gonna draw that column first. So I'm gonna leave just a little space over here, and I'm gonna draw, here we go, H. Below the H, I put a C. Below the C, I put another C. Okay, then I got another H. All right, then I skip a little bit of a space, and then I have an O, and then below that I have a C, and below that I have an H. And before I do anything else, I'm gonna look at it to make sure I'm good. Okay, I have an H, I have a C, I have a C, I have an H, I have an O, I have a C, I have an H. So we just drew the center column. Okay, now I can work my way down and across to figure it out. So, little hookup right here, they're linked. Little hookup right there, they're linked. Little hookup there, they're linked. Okay, now we're linked to the side from this C to another H. Okay, we're linked to the side from the C to an O. And then we're linked to the side to an H. Okay, then down here we have our carbon is going to be hooked across here to another O. right? This carbon is also linked down here to a C. All right. Let's see here. This C has an H above it. Okay. And then down here we are hooked to another C. And down here we're hooked to an O. And over to an H. Okay. This C is hooked down to the H. This guy's hooked up to the O. This guy's hooked to an H. Okay. This guy comes across to another C. What happens if you guys get a little behind me? Who cares? It's on the board. You lose. You lose. Right? I'm just reminding you guys because I see a lot of you guys trying to keep up with me. It's on the board over there. I just wanted you guys to see it as I do it here. Okay. H. Okay. This guy comes down to an H. And this guy comes down to an O and then over to an H. Whew. Sugar, sugar. All right, so let's talk about this real quick. We talked about carbon, okay? Carbon's a rock star on this one because carbon likes to hook up, but let's just look at this particular carbon right here, okay? So carbon has an atomic number of what? 6. How many valence electrons are in the first shell? 2. How many are in the second shell? 4. How many does it want? So how many does it need? Ready? 1, 2, 3, 4. Is carbon happy?
Yes, it is.
Oxygen, look at this oxygen right here. What's its atomic number? 8. How many valence electrons, or how many electrons in its inner shell? 2. How many in the outer shell? 6. How many does it want? It wants 2 because it needs 8. Okay, so when it has 2, look, gets 1 from carbon, gets 1 from hydrogen. Is it happy? Do you guys see how this whole thing is held together? Okay, so you guys, this is the sugar, and then what do we have left?
Oxygen.
Oxygens, and these guys come in the form of OOs. Okay, so we got our OO, 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 OO. O'Reilly? Okay, good. All right, cool. All right, now you guys, not only do you have a balanced equation for photosynthesis, you also have a chemical model so you guys can say why it does and how it does what it does. Okay? Photosynthesis is plants collecting photons from the sun. Photons are all the energy for all of Earth. Okay? It's kind of crazy that if we think about any energy you get, it all comes from the sun and it all goes through plants to get to us. Pretty crazy, right? Does that make sense? Okay. Cool? Alright, so now I'm going to slide down the screen. Guess where we're working next? The next, so it's not the bottom half, it's really like the bottom half of the upper half. Okay, yes, we're kind of in the upper middle. Okay, alright. And so you guys, guess what we're going to write right here? Cellular respiration. So I'm just going to write respiration right here. And who does respiration? Animals do respiration. I don't know why my panda is either frowning or has a mustache. I'm not sure.
I thought that was the cat.
Hey, the dead cat goes on the other side.
Oh yeah.
Okay, but this just represents any kind of animal, okay? We might have we'll have a panda on tomorrow. It'll be a good time.
Alright.
Now he just looks creepier. I don't know. I can't fix it. Can't fix creepy. Some of you guys know that. Okay, we're gonna move on. You could draw a penguin. Is that what you said?
No, I want to put a cat.
Well, I would be nervous putting a cat. Why? Is there already a cat on ours?
Yeah.
Where's the cat live? It's a dead cat. What's his name? Pause, and it's a cat ion. So yeah, I would veer away from cat, but you can put any other number. Okay, put a cat. You'll be fine. All right, guys. So check it out. So what's funny is now I have to like totally remember the equation. Do I have to remember the equation?
No. It's reversed.
Oh, it's reversed. Eric, flip it and reverse it. Okay, so check it out. What we do need to realize, though, is there's a different reason for doing respiration. People think we need to do respiration to breathe, but it's not about breathing. It's about actually using the oxygen to process out energy. So before we had a sun on this, Now we need to have energy. So this is my sad version of a lightning bolt. Let's see if it's better than last hour. That wasn't so bad. So that's my lightning bolt, okay? And it's an ATP. The goal is for our body to release energy in the form of ATPs, okay? And so on this one, we're gonna start with our sugar. What's the equation for sugar again? C6H12O6. And then what do we need? We need O2s. We need oxygen. Okay? All right, so we got that side. So we got sugar and oxygen. And then when that reaction goes down, we're going to get energy. But what are the byproducts that we have? We have 6 what? CO2s, which is carbon dioxide. Okay, and so we got our energy. We got this. And then we got, what else do we breathe out? Is it funny to say we breathe out water? Totally is, but that's what we do. Okay? Now we're going to start out with our difficult drawing again. Alright, so I'm going to come to the side this time so we have a little bit more room, and I'll move this guy over. Okay, so I'm going to start right here, and I'm going to go with my H. I'm going to go with my C. I'm going to go with my C. I'm going to go with my H. Okay, then I'm going to skip a little space. I'm going to go with my O. Alright, and then I'm going to go with my C and my H. Okay, so I'm going to double check that before I draw the rest of it. I got an H. Let's see, I got an H, I got a C, C, H, and then I got an O, C, H. Cool. Alright, so I'm set now to start drawing this. You guys set to draw it? Alright, let's knock out our sugar. Here we go. So we link here, link here, link here. Here. Okay, link down to here. C over here. Change it up a little bit. What are we going to draw after you guys get your sugar drawn? The O's, okay, our oxygens. Now I promise you guys, yes, this is ridiculous, but you guys will be so happy to have this when you guys take chem. So once I grade this, you're going to want to put it someplace safe. Someplace like you don't clean a lot, like under your bed, or maybe in your normal textbooks you don't use. Okay. All right. So do we have the molecular structure drawn for all of our reactants? All right. So I'm gonna slide this over, and we're gonna move on to our products. Okay. So we have. COs. And we have H. Okay, how many of you guys have seen these drawings before? And you're like, yay! How many of you guys kind of understand how they work now? Okay, those of you guys who haven't seen these drawings before, do you understand that all these guys are just trying to fill out their outer shell of valence electrons? And that's why they're hooked up the way they are? Okay, do you guys understand that it takes energy to make this happen, but it releases more energy? Okay, so there's lots of things happening in your body. We're bringing glucose to your blood or to your cells. So glucose is traveling through your blood to your cells, and your cells do this reaction. Is the sun involved at all in this reaction?
No.
No. When was the sun involved?
Photosynthesis.
During photosynthesis, when the plants did us a solid and made us the sugars that we end up doing. And then what do we do for plants? We pump out carbon dioxide for them to eat. Okay? Kind of funny way to look at it, right? Okay? All right. So for today, let me zoom back out of this guy. Okay. Ooh, that looks pretty, right? Okay, cool. So this is where we're at now. This is what the back of your page should look like. There's probably some stuff on the bottom, like a square down here or something, right? We probably have like this mess down here, right? Do you guys have these guys or something like that? It's more over, yeah. So you guys have that, but this is where we're at now. Tomorrow we're gonna work in the center area. For today, you guys have to start your last chapter. You have to outline before Christmas. So this will be your last time you guys outline until next year. So you guys are gonna do 7-1, 7-2 outlines. Okay? Good job, guys. 7-1 and 7-2 for tomorrow.